Amir Jaberz. Right here. Hi, Amir. Amir is a research scientist at Bayesian Decentralized Computation Protocol Project. He's going to share with us how to build an effective and scalable cloud-based face recognition system. Let's welcome Amir.
Basic explanation of what is facial recognition, the concepts, and then some more technical concepts. What are the models? What is the state of the art? And then how can we implement it? I start with giving some terms here. What is recognition in general? It depends on what you're talking about. If we talk about what it is, it could be a object and scene recognition. If the question is who is it, then it could be identity recognition. If it's about where is it, then it would be object detection. And what are they doing? It would be activity recognition. And these are all classification problems that we have in machine learning and computer vision. So the question is that we have a list of classes and want to just associate one of these classes to the activity or to the object that you're seeing. The other term that I want you to learn is biometrics. Biometrics is just a measurable characteristic of a human being. It could be automatically recognized or to verify the person using that metric that we are measuring. So it could be physiological. The measurements are derived from the human parts, like eyes or hands or face, or it could be behavioral. It depends on what kind of action you're doing. Some examples you may know about it is finger scan, the voice detection, facial recognition, iris, retina, hand, and signature recognition. These are the examples. So the facial recognition system is a technology that can match the human face from digital images, or it could come from the videos. And we're looking at a database, so we have millions of people in the database, and we're trying to associate the person that we're seeing among these data sets that we're looking at. And we are trying to measure the facial features of the person, and we associate or match that person with the data set that we have. Facial recognition came a long way. Just for the last 6-7 years, the error rate came from 4% all the way to 0.08%. It's like 500% increase. And then we are estimating that over 800 million people will use by smartphones the facial recognition by 2024. So the tasks that we have in facial recognition are verification and identification. These are two similar tasks, but very different in terms of compute that we need to put into it. The verification tells if this person that we are looking is the one that we have in mind. So the question is this Mark? And the identification, we don't know who is the person. We just want to identify it in all the data sets that you have. So it would be a much more challenging task, the identification. I just want to give you some examples of facial recognition that you may know. It will be useful in surveillance, security, counterterrorism. It could be used for healthcare or for daycare to see who is actually picking up your child, or who is helping you in the healthcare department. It could be used for access control, for residential houses. It could be used for voter verification, for facial identification for banking, like at the ATM machine. It could be used at cars. I think the ones that are maybe more relevant, people see the most is in social media. There are a lot of like filters that people use, Snapchat, and called animated lenses. An Apple ID is another example that you can actually change an avatar based on your face expressions. So in order to know how it is actually working, what kind of features or information is using to know that knowledge, we have around 80 different nodal points in the face that we can actually use for facial recognition. Some of them are like distance between the eyes, the width of the nose, the width of the lips, the depth of the sockets of the eyes, and you can see the other ones, the jawline, chin, and you can find much more. So there are 80 of them. I just give you some examples here. You see the distance between eyes and the width of the lips. So the model, when it's learning, is trying to learn all these features at the same time. There are some challenges here. The model will be misled, or it will be confused by some features that happens by humans, like for example with their behavior, if they have a different hairstyle, if they do makeup, if they grow beard or the hair is growing, or if they have, for example, glasses. There are also some other phenomena that can happen and can just change the accuracy of the model. It's based on acquisition. And for example, if the posture of the head position is different, it can make difference. Or if the lighting is different in different scenarios, can also change the way that the model has learned. In order to overcome these drawbacks or problems, several technologies have been developed. Some of them are actually sensor-based, and some of them are post-processing technologies that has been created. 3D cameras are one of them. So as you see in the picture, instead of having just one camera looking at the person, you can have multiple cameras in different angles, from the side, from the angle, and then there's this grid of points that is presented to the face of the person, and the cameras try to understand them based on their location and coordinates. The pros of using these 3D cameras is that it can actually learn the shape. It knows about the contour of the eyes. It knows about the contour of the nose. It actually knows how much the eye or the nose or the chin has the curvature, so it understands that. This helps the accuracy, so it will not be wrong, or the accuracy will not suffer in terms of when we have a dim situation or low light. But the problem is that you still have problem with facial expressions, and you need to have like new hardware to actually use for these 3 cameras. The other one, sensor-based technique that I think the Apple ID also use is these thermal cameras. There are these infrared cameras that ignore the subject's accessories, because they're basically using the heat emitting from the face. So whatever accessory that you have, glasses, hats, makeup, they will not affect the sensor. And they also work with different light conditions. You don't need to have light to capture this kind of information. You don't need to have flash with the camera, so the location of the camera will not be exposed in terms of you don't want people to know where the camera is. But still, the cons is that the data sets that you need to have in order to train your models are very limited. Not everybody has access. The data sets that we have, the normal cameras are much bigger and more. With the thermal cameras are not as widespread, and also you need to have this extra hardware to do the detection. The post-processing technique can also help, like this method called skin texture analysis. you don't need to have like a specific sensor for that. And instead of looking at those features like the distances and the curvature, it looks for these, it measures the difference between these pores of the skin. So it's much finer scale. It's trying to understand the texture of the skin. And the good thing is that it's so accurate that it can also detect the difference between two twins. So it understands the twins and distinguish between them. If I want to go, now that we understand the application and the challenges that the system has, the facial recognition system has, let's see what are the steps that we need to do that. We need to detect the face. So imagine that we have this video of people coming into the scene, or we have the image of them. So the first challenge is to actually find the face of the person. This is called face detection. And there are multiple models that I will go through later on that has been developed for years to just detect the face of the person among the other objects that are in the scene. The next one is to do alignment. So as you remember this picture, the bottom one, the person's head is not like perpendicular to the camera. So the landmarks, the white points that are visible are different. The shape of them, the distance with them is different. So the model will be thrown off by this information. So you need to align the head posture in order to be in 35 degrees to the camera. So this is called alignment. You need to actually move the head or move the image in order to for the head to be visible in front of the camera. And then you have this representation. So you need to pass that aligned face to a deep learning model, and it creates a coded version of this face in a lower representation space, and that would be computationally less expensive. It would be more informative. It would be more rich to compare only in that coded space. So with this, we need these representations. And the last one is to verify. So when you actually bring your picture into this coded space, now you can compare it with other images in the same space. And that's called verification. So when you do that, then it will give you some certainty that I'm sure this is the same person that you're looking for, or this is not. In order to train models in facial recognition, there are multiple public data sets. I listed like a few of them here, but there are more than like 15, 20 that I could find. There are large data sets. They're mostly based on celebrities. So that could be a challenge that like normal people will not be represented as much. What we need to consider to create these data sets, if we want to build such a system for ourselves, is we need to have diversity in terms of gender and ethnicity in the data set that we're building. We need to have this variance of lightening, angles, and facial expressions in the data set too. We need to have different resolutions of the images. So images with high resolution, low resolution, this should be all of them in the data set in order for the model to behave well or generalize as much as we want. The other thing that we need to consider when building these data sets for training is the security and privacy. The user data must be encrypted. You cannot just like pour data in a non-encrypted way and train the models with. And then they need to be purged after being used. We need to consider if the model, the data that we're using gives us a good accuracy at the end. Is it enough, or do we need more data to do that? Is it scalable at the end? Can we generalize it? And at the end, we need to be transparent about ethics of the data set that we're using. If we are just scraping data from the internet, or if we're just violating anybody's privacy. In terms of models, I try to look at the models that are state-of-the-art and people are using with good accuracy and good performance. And there are many of them. I have a list, I think the next slide, that compares these methods. In terms of like individual models, we have is in the detection phase, we have retina phase and SCRFD. For alignment, we have STUNet and then coordinate ray. And then for recognition, we have arc face and VPL. These are the famous ones. But there are other ones that you can see in the graph too. Each one has its own accuracy and performance in terms of the time that it takes to respond. So the solutions that are available for facial recognition could be SaaS-based. So it is on the internet. You pass your images to a server, and then you get the response if this person is who you are thinking or not. So the pros for this kind of system is that it is easy to operate. So anytime that they have a new data set, they train it, they can easily just swap the model. It supports high load of input if you have multiple cameras, if it's easily scalable, and it can easily integrate with APIs. So if you have an application or software, you just want to call some API on internet and get the response, you can easily do that. The problem is that these are mostly very expensive compared to the other solutions you can do on-premise, and then requires internet to actually do your matching. If you have a situation that you do not have access to the internet, you have this device sitting somewhere and it's an edge device, you cannot afford that kind of speed, then you'll have problem with, and then it also has these security issues with the data breach, as it requires to pass all the information to a server. There's also self-hosted solutions. It can also be like REST with the REST API, so you still can do it like in a requested as a server base. It could be both on-premise, so if you want to do it in a like inside your own network, you don't want to pass the information outside your network, you can do that, or you can actually put it on the cloud and use it. So the benefit is that because you are the one who's managing all the servers, so the cost will go down. And the other thing is that the data is stored on your own system, so it's like more secure in terms of violating people's privacy. It can work offline, so you may not need to have all the time the internet available. And then it is scalable, so you can actually go and you can make it scalable by using containers like Docker containers. The cons is that it needs to be managed by you, so you need to have the skills to actually do that. So I was comparing a bunch of free packages and paid packages that are available, and like trying to see what are actually the parameters that they should look for in terms of accuracy, speed, what kind of tasks they're doing, if they're giving us like the API that we need for that, or if it actually runs fast in terms of performance, does it run on CPU or GPU, and what kind of models it gives us to play with. So I think DeepFace, I chose DeepFace to be a good model to play with at the end, but the other ones are inside face, and actually some of them are not visible here. But there are like around 8 or 9 open source packages that you can play with. There's also paid packages, as I said, like these are SaaS-based platforms that you can go and pay. And as you can see, Microsoft has it, Amazon has it, Facebook has it. The other companies are providing it, but as you can see, the price is pretty hefty. So for every 1,000 calls that you have, you need to pay like $1 or $2, and you can easily grow. Imagine that you deploy it somewhere, and people are just coming and coming and coming to the hundreds of frames or thousands of frames every hour that you need to actually call the server. It would be very costly. I just wanted here to show you how actually the code looks like. So this is DeepFace. It is a Python code. You can have these two arrays that you can play with the different models for different tasks that we talked about, detection and representation. So you can change them. And then there is this package called DeepFace.verify, this function you can actually use to see if the image 1 and image 2 actually are the match. So here we have two pictures here. And we just pass image 1 and image 2 to this verify function. And then we also choose the models that we want. And as easy as that, we can actually get the results that you can see at the bottom of the image, that it is verified, it is true, and it also gives you the certainty, how certain it is, based on the distance, and like more information, what kind of models has used and so on. Most of these models, they do other tasks too. It was in the previous slide when I was comparing these features. And one of them is, for example, emotion recognition. And here this function of analyze for DeepFace is doing this. So you can actually create this action of emotions that you're looking for and pass it to this image, and you can see if actually it can detect what kind of emotion is in that image. And again, you can see the certainty and if the emotion is available or not. But still, with all these improvements, still there are easy ways to fool these facial recognition systems. There are visors that you can actually go and buy. It could be active. There's some LEDs that can fool the system, or they could have some patterns that the model have never seen. So it's like a cat and mouse game. Every time people come up with ways to fool the system, then companies can also put it into their training and then fix that. But again, people can find ways to fool the system. There is also, as you can see, these artists that find ways to fool the facial recognitions with their makeup and then with hairstyle. And also there are softwares that help you to be unrecognizable. So as you can see in this, they call it cloaking. And on the left, the original image is your picture, and on the right one, on the cloaked image, it adds some kind of pattern or noise which is unrecognizable for humans, but it makes the computer to make a mistake. The last slide that I want to talk about is actually about the cost of deploying these systems. Facial recognition is a extensive compute task. You can have millions of people in your database to compare your subject's face against. And you need to deploy it in a way that can handle that, so it should be distributed. The databases that you use is important. And as you can see, the order, here I bring back this comparison between face verification and face recognition, and the complexity of it is the order of 1 to the order of n. So it is much more complex to do the facial recognition task. And you need to consider really to use a better fault tolerant and more performant database to handle this kind of task. I appreciate your time. Answer any questions.
Any questions for Amir?
Thank you so much.
If not, then thank you, Amir, for sharing with us applications, methodology, challenges, and solutions for face recognition system. Thank you, Amir.